So we're going to jump off on our discussion of what are variables, what are constructs, what is operational definitions, and kind of start building on the idea of what are the rules that we use in operational definitions to assign measurement, and also how do those relate to reliability and validity, two other terms that we are using a fair amount in this particular lecture. So one of the first ways that we can think about any type of variable is how we're going to categorize it based on the type of data it is. Qualitative versus quantitative, categorical versus continuous. So the first question is qualitative versus quantitative. Quantitative means numerical. It means that whatever the data is, we're assigning numbers. Now those numbers may not have any numerical value. For example, if it is categorical variable, for example, biologically male versus biologically female, we could assign that 1 and 2. We could assign it -1, +1. We could assign it 0, 1. The numbers really don't have meaning. They simply are labels. But if the numbers actually have meaning, 1 means less of something, 5 means more of something, that tends towards more of what we call a continuous variable. So the first question is, again, is it quantitative, numerical, or is it qualitative? There's nothing wrong with qualitative data. This class is mainly going to focus on quantitative because its focus is on statistical techniques, which is mathematical, which is involving numbers. But a lot of psychological research is qualitative in nature. A lot of major theories about psychology started as qualitative psychology or theories. A qualitative one is basically any kind of data that is actually qualitative. What qualitative means is kind of verbal, it's information. So if someone tells us a story about why they have a certain emotional reaction to a movie, I'll use a quick example. If you were asking me what are my thoughts about the movie The Empire Strikes Back from the original Star Wars trilogy, movie 2, though technically I guess if you're a nerd it's movie 5. Not to put a label on that, but still, there's even a discussion there. But the movie The Empire Strikes Back came out when I was 10 years old. The day it came out was the day that the dog I had been raised with, basically my best friend in the entire world, had died earlier that day. Not only that, my mother was away at a hospital for a procedure. I'm still not exactly sure actually what she was in the hospital for. I was never told, and no one's ever talked to me about it, even now that I'm a much older adult. However, that meant that my father, who really wasn't in charge of the emotional needs of his 10-year-old son, was struck with how do I deal with this 10-year-old child being so stricken with the loss of his beloved dog. I know, I'll go take him to a movie. And he took me to the opening night of The Empire Strikes Back. I am a huge fan of science fiction of all types. I am a huge Star Wars fan. Therefore, watching this movie the day it came out, having lived and breathed waiting for it, was an incredibly positive experience and one that I have a strong feeling of connection to my dad for. But at the same time, it's impossible for me to watch that movie without feeling deep sense of loss and basically grief over the loss of my childhood companion. That would be qualitative. There's really no way to put a number to that. I mean, you might be able to have someone rate it on how depressing it is, but generally speaking, what we're really interested in here is the quality of the information. If someone just used that to assign me a scale on a 1 to 5 of depression at, say, a 4, that's really missing the point. In other words, reducing that story to a quantitative element just isn't very valuable. And it loses all of the quality that's involved in that story. However, if someone simply asked, how depressed are you right now on a 1 to 5 scale, that might be something that makes more sense to be quantitative. So that's our first question. Is the data qualitative? In other words, can we reduce it to a number? When should we reduce it to a number? And the second question is, once we reduce it to a number, is that number representing categories, or is that number actually representing more or less of something, continuous? So those are the two big questions that we're going to ask of all data, and each of them is going to lead us to further questions. So the level of measurement, the relationship of the values that are assigned to the attribute for a variable. So example, we might have party affiliation, Republican, Independent, Democrat. So the variable is political party affiliation. The attributes are groups, Republican, Independent, Democrat. The values are 1, 2, and 3. Is there a relationship between those numbers? They're arbitrary. There is not a relationship. I could easily have Republicans 3, Independents 2, Democrats 1. I might actually make Democrats 1, Republicans 2, and Independents 3. The numbers don't necessarily have a relationship. They're simply values. Also, when we have categorical variables, we also want to ask the question, is that categorical variable truly capturing all the representations? So, for example, does independent really capture both, for example, libertarians and Green Party members? They're both technically independent, but they would both argue that they're not independent, that they're their own political party. It's just a smaller party. So again, we want to think about that as well whenever we're talking about this. So in this case, we don't really have a relationship with those numbers. Now, in this case, I might ask someone about their life satisfaction. How satisfied are they with their life? So again, the variable is life satisfaction. The attributes are a 1 through 5 scale, with 1 representing unhappy with their life, 3 representing being neutral about their life, and 5 being very happy with their life. At this point, we now are still assigning numbers to categories of a construct. So we have a variable, we have attributes, we have values. We're using a rule to assign that. However, this time we do have a relationship. So that relationship is there. People that rate 1 or 2 are less happy, we're assuming, than people that rate a 4 or 5. So when we're looking at scales, we have 4 questions to ask, and these are ipsitative. In other words, as you go up this scale, you're going to include all the previous categories. So the first type of scale only has identity. It's a categorical scale. All it has is identity. The next level is to add magnitude. So numbers now go in a direction. So we now are in a kind of quasi area. Depending how many questions we ask or how many attributes there are, this may still be categorical. For example, we could ask, are you happy? Yes, no. Well, no is 1, yes is 2. There is magnitude, but that's probably still more of a categorical scale than a continuous scale. As we add on top of magnitude, we can add equal intervals. And this is kind of a fuzzy gray zone. This is approximately equal intervals. Generally speaking, statistically, we've found that if you have 4 or 5 or higher number of items, and it's on some form of balanced scale, strongly agree, strongly agree, neither, disagree, strongly disagree, that's considered equal intervals. If you assign 1, 2, 3, 4, and 5, it's approximately an equal interval between 1 and 2 as it is between 4 and 5. The truly best type of scales have an absolute 0. All absolute 0 means is that 0 means 0. It's not a random number. So for example, on that equal intervals that I mentioned, that 1 to 5 scale, strongly agree to strongly disagree, I'm assigning 1, 2, 3, 4, and 5. I could easily assign -2, -1, 0, +1, +2. It's the same scale. It's the same intervals. It can still be used the same way as a continuous scale. However, the 0 doesn't really matter. It's simply what I'm assigning. Higher numbers mean more of something. I could also flip it around. Lower numbers mean more of something. The equal intervals is still there. The magnitude is still there. The identity is still there. But the absolute 0 isn't. Absolute 0 is usually going to be behavioral count or physical scales. In other words, when we're talking about absolute 0, it is the best type of scale. The numbers have equal interval, they have magnitude, and they have identity. And they also mathematically mean 0. So if you say, how many books have you read last month? And you read 0, the 0 means something. 0 is 0. 3 is 3 books. 7 is 7 books. So notice that there's a lot of things we want to measure, constructs, that we really can't get to absolute 0. But we should always be thinking of, as we create scales, as we create measurement, the more we can capture identity, magnitude, equal interval, and potentially absolute 0, the more we can do with those numbers when we're done collecting the data. So let's go through each one of the types of scales. A nominal scale is literally identity alone. It's a qualitative scale generally, and it's a categorical scale. So it's the simplest type of scale. It's meaningful but arbitrary. So for example, types of runners. 1 equals a 100-meter runner, 2 equals a hurdle runner, 3 equals a marathon runner. It gives us qualitative information. We can tell if we have 7 3s, we have 7 people that run marathons. If we have 3 2s, we have 3 people that run hurdles. If we have 0 100 meters, no one runs the 100-meter race in this particular sample. But the numbers are arbitrary. We could easily assign this 0 1 2, -1, -2, -3. And being a marathon runner at 3 doesn't mean that you're twice as good as a 100-meter runner. The numbers are arbitrary. So again, we could easily switch these numbers up, and it really doesn't matter. We're simply giving numbers to categories, which allow us to do additional numerical statistical analysis. But we have to remember that it's up to us as the researcher, as the person in charge of what we're doing, to know what the scale is. There are many scales that we are interested in psychology that are nominal. We might be interested in the difference between Republicans and Democrats on a particular opinion. That would be a nominal scale. We are giving it numbers. One is Republican, two is Democrats, but that's all those numbers have. They have identity. They have no other meaning. So nominal measurement, the values name the attribute. No order is implied. For example, football jerseys. Player 32 is not twice as good as player 15. They might be, but those numbers are simply just names. They're ways to keep track of things. They're not necessarily representing any kind of order or magnitude. The next type of scale, when we're looking at nominal scales, we also want to ask, is it a dichotomous question, or is it a question that allows additional answers? So a nominal dichotomous question, dichotomous is just, again, a funky way to say two. So what is your gender, male or female? So a lot of people would argue that's not really a good question anymore. That should be, what is your biological sex? And even that can come up to a little bit of a debate as well. Do you like to play basketball? Yes, no. Do you drink? Yes, no. Notice that nominal dichotomous questions does allow us to look at categorizations and can make us allow us to look at differences, but it's also a fairly blunt scale at a dichotomous level. The reason we need to identify if a nominal categorical scale, and again, nominal scales are automatically categorical scales, is to allow us to determine what analysis can we use. There is certain analysis that we can only use with nominal questions that are dichotomous. There is other types of analysis that will allow us to look at questions where the nominal scale has more than two answers. So for example, you could have check each event that you've experienced the last month: change in church activities, change in eating habits, change in a financial state. So this would be an example of, again, labels. So 1, 2, and 3, but it also gives us information of what you're actually doing. So this would be a non-dichotomous question. But each individual question is dichotomous. Have you experienced a change? It's a yes, no. Change in church, change in eating habits, change in financial status. The next type of scale is an ordinal scale. It has quantitative, and it can be quantitative or categorical. It really depends on how it's set up and what you're looking at. And as far as statistical techniques, it's going to be up to you in a theoretical way to defend if you use an ordinal scale as a quantitative scale compared to just a categorical scale. In other words, we're in a gray zone here when it comes to statistics, and we'll talk about that as we hit various statistics. So this scale does have an ordinal scale, unlike a nominal scale, has identity and magnitude. So again, a nominal scale is just identity, and it can also be a dichotomous nominal scale. An ordinal scale has identity and magnitude. So the numbers might designate rank. For example, placement in a race: first, second, third, fourth, fifth. That's an ordinal scale. We know first did better than second. We know second did better than third, and so forth. However, what we don't know is, are there equal distances? So for example, first place might have done it in 10 seconds, which was 3 seconds faster than second place, which was 4 seconds faster than third place, which was also 4 seconds faster than fourth place, which was only 2 seconds faster than fifth place. We don't have this information with an ordinal scale. We simply know the order. So someone might say that they are higher on something, but we don't know that there's actually an equal difference. So again, those differences are going to vary depending on what the actual outcome was. So whenever possible, if you have an ordinal scale, you want to ask yourself, could I simply just move forward? So for example, on this particular example, I wouldn't use placement, I would use actual times. That would get me to a higher level of scale. So ordinal measurement, when attributes can only be rank ordered, distance between the attributes do not have any meaning. So sometimes there are questions that basically are equivalent to ordinal measurements. For example, we might have a measure of educational attainment on a scale where basically someone rates how much schooling they've had. 0 equals less than high school, 1 equals some high school, 2 equals a high school degree, 3 equals some college, 4 equals a college degree, and 5 equals post-college. The question here is the distance between 0, less than high school, and 1, some high school, is that the same as some college versus college degree? Is that distance the same? And that's a harder argument to make. So generally speaking, a lot of times when we see ordinal scales, it's often that we weren't in charge of measuring the information. We're using pre-existing measures that were ordinal. Whenever possible, if you're creating a study and you're planning on a measurement and you go, this is an ordinal scale, I think it's always worth asking, is there a better way to measure this? So for example, in this case, instead of asking educational attainment, I might simply ask, how many years have you gone to school? Assuming that you started school at the age of 4 or 5, then simply calculate how many years you've been in school. That would give us something beyond an ordinal measurement. An interval scale is generally the gold standard of most psychological research and most of the statistical techniques we're going to talk about. It has identity, magnitude, and at least in theory, equal intervals. And this is one of the concepts that some students struggle with a little bit because honestly, equal intervals is approximately equal intervals. It's not necessarily that we're going to have an exact equal interval. It means that theoretically, it's good enough for the purposes of our mathematical equations. So for example, we might have ratings, how fast is the runner, with 1 being extremely slow and 7 being extremely fast and 4 being average. That might be a self-report or an other report on someone's speed. And that's going to give us a scale, an interval scale. Now notice that we might actually want to go back and know better how they actually performed in a race. So there's not always going to be necessarily theoretically the very best way to measure, but as far as our statistical techniques, we're wanting to see something that has this equal interval. One of the ways to detect if something is equal interval is you can ask, is it a symmetrical scale? In other words, if you have a 1 to 4 scale where 1 is extremely unlikely and 4 is likely, that's probably not an equal interval scale. But if you have a scale that starts at extremely slow, ends at extremely fast, and has a midpoint average, that probably is going to be considered an interval scale. So again, we have our various ratings, and at this point, we can make an argument that these numbers are generally going to be equally distant from each other. Now, I do want you to know what's still missing here is 0 having meaning. The numbers are still somewhat arbitrary. 1, 2, 3, 4, 5, 6, 7 could easily be -3, -2, 1, 0, 1, 2, 3. Our statistics are going to treat these exactly the same. They could be 100 to 700. It really doesn't matter what the numbers are. It simply matters that they are symmetrical and equal. In other words, if I have 100, I wouldn't want 100, 101, 120, 170, 200, 500, 10,000. That would not be an equal interval scale. But assuming that the numerical difference between the numbers is the same, 100, 200, 300, 400, 500, 600, 700, or -3 to +3, and that the labels are symmetrical, extremely slow to extremely fast, strongly disagree to strongly agree, we generally can treat those scales as continuous, quantitative, with identity, magnitude, and equal interval. So this is what we're looking for most of our statistics. When possible, we want to make sure that we're measuring or manipulating our IVs and our DVs, our interval scales, if it makes sense for our research question. Now note, there are things that simply don't lend themselves to interval scales. If you're looking at the difference between people that are under 18 and over 18, you're probably not going to be able to use an interval scale. Finally, when we're talking about different types of interval measurement, it's when the distance has meaning, but we don't have absolute zero. So for another example, temperature in Fahrenheit, the distance between 30 and 40 is the same as the difference between 70 and 80. We have equal distance. However, the ratios don't make sense. 80 degrees is not necessarily twice as hot as 40 degrees, although the attribute values are. And most scales of measurement, 0 is simply a point on the scale. In other words, it is a temperature. In metric, it's actually it's where water freezes, so it's 32 degrees. In Fahrenheit, it's actually below freezing. It's kind of an arbitrary level of zero. Neither of them actually represent an absolute zero, the coldest it possibly can be within our physical universe. That would be a Kelvin scale, which wouldn't be interval. So continuing on interval scales, the most common interval scale in the measures of social psychology is called the Likert scale. Some people pronounce this Likert, but if you actually look up on Google, which you now can, it is pronounced Likert. The Likert scale, in true Likert scale, is an agreement with statements on a 1 to 5 scale: strongly agree, moderately agree, disagree, moderately disagree, strongly disagree. So that's actually typically what we'd be seeing, but that is actually a Likert-esque scale, a Likert-like scale. Notice there's 6 items. A Likert scale has a midpoint. It's a 5-point scale. Strongly agree to strongly disagree, with 5 being either neither or neutral. So whether it's a Likert scale or a Likert-like scale, these are generally considered to be interval scales as well, and are a common tool in the research of psychological constructs. Our final type of scale is the ratio scale. It is continuous and quantitative. It has identity, so the numbers do represent real-world observations. It has magnitude. Higher numbers mean more of something. It has equal intervals. The distance between 1, 2, and 3 are equal, and ratios make sense. 4 is 4 times as high as 1, and it has an absolute zero. In other words, zero has meaning. It is the most complex type of scale. So runner time and finish. So 0 seconds would be someone would be able to complete the race, whatever the distance was, in 0 seconds. 10 seconds is 10 seconds, 15 seconds is etc., 20, 25, and 20 seconds means the person took twice as long as someone who took 10 seconds. For the purpose of statistics, generally, if we have an interval or ratio scale, we can use the same statistics. The advantage of the ratio scale is it's usually more meaningful, and we can trust those statistics more easily. So again, as we have various people rate on that scale, we now have identity. So we know someone with a 10 is better than someone with a 15. We have magnitude. The numbers do have meaning. In this case, smaller numbers mean faster running. There is equal interval. So 10 seconds, the difference between 10 seconds and 15 seconds is exactly the same as the difference between 15 seconds and 20 seconds. And we have absolute zero. Zero has meaning. This could also be length of runner's legs and feet. So again, 0 feet means you have 0 length. 1 foot means you have 1 foot of length. And this would be, again, an example of a ratio scale. So ratio measurement has an absolute zero that is meaningful. So basically, can your construct be a meaningful ratio? For example, number of clients in the past 6 months, that would be a ratio scale. The number of times you do something in a set of time would be a ratio scale. A lot of behavioral scales, think of research with rats and pigeons, was counting the numbers of behaviors, and this counting was often done mechanically. Those would be examples of ratio scales. The number of times a rat pressed a bar in 1 minute, if they pressed it 0 times, 0 is meaningful. If they pressed it 1 time, they pressed it once. If they pressed it 4 times, that's 4 times more than the rat that pressed it once. So this basically creates a hierarchy of levels, with nominal being the bottom, categorical only, attributes are only named. It's the weakest type of measurement. Ordinal, we can now order those attributes. Again, the numbers are arbitrary, but we have an order. So first, second, third, or fourth, but we don't have that equal distance. Interval, the distance is now meaningful. We have assumed equal distance between the values, and this is usually going to be a symmetrical scale. And finally, we have ratio absolute zero. Whenever you're creating a study or evaluating a study, it's a good idea to ask, what are their variables and how did they measure them? Are they nominal? Are they ordinal? Are they interval? Or are they ratio? Because this is also going to give you some information of what the analysis they did, what they can do, and what conclusions they can draw from that data. So let's end off with talking about reliability and validity. So reliability is the consistency and repeatability of a measure or observation. Now, again, there is a pretty big assumption here. The assumption is that the constructs that we're interested in measuring are reliable, that they're relatively stable over time. And most psychological constructs are. If you're an A student, you probably were an A student 2 years ago, and you'll probably be an A student a couple of years from now. If you are highly extroverted, you probably are extroverted now. You were extroverted in the past, and you are extroverted in the future. Now, there should be a notice there is some development, and there can also be extreme cases where people do change over time. But generally, most psychological constructs are fairly well stable by the time we hit adulthood and generally stay stable through the majority of our life. That means that we can be looking at the reliability of variables as one of the ways we determine, are we actually measuring what we think we're measuring? Are we measuring it reliably? Do we find consistent and repeatable measures of observations? If we record someone doing a behavior and we have 3 different people watch that recording, do they come up with a consistent answer to how often the person did the behavior? That would be reliability. If we give someone a personality test and they're highly extroverted and we give them the same test 3 weeks later, do they also continue to show highly extroverted? If you scored really well on the first test, do you also score really well on the second and third test? Generally, those would be, again, examples of consistent and repeatability of the measure or observation. It should be noted, though, that whenever we're measuring anything that we cannot directly put on a scale, which is most of psychological behaviors, what we're really looking at is the true score, which is equal to observed score plus error. In other words, we can never truly know how extroverted you are. What we can do is come up with an operational definition that allows us to put a number on your extroversion, which is going to be plus or minus some level of error. And even reliability, we're not going to find the exact same score. So if I take an extroversion scale today, I'm actually in a pretty good mood and I'm enjoying interaction with people. I'd probably score a little higher than if you caught me on a day where I'm in a bad mood and I'm really not wanting to hang out with people. I'm still going to probably show up as relatively extroverted on both scales, but there's going to be a little bit of difference on my personality, what's going on in my life, how I'm looking at the world. That is error. It may also be I just misread a question. There's a lot of places that error can come in. The important thing to recognize here is that though we're trying to reduce error, that our observed score is as error-free as possible, we never truly understand what the true score is. There's always going to be some error in our measurement. So are the observations or judges measuring the same thing using the same measure? This doesn't tell us that they're actually measuring what we think we're measuring. It's basically just telling us, are we actually measuring the same thing reliably? Think about if we had people use a measurement to determine how tall someone was. So they had a measuring tape. We could probably get 3 or 4 people to all agree on the same measurement. But if we then declared as researchers that height meant how smart you were, it's a reliable measure, but is it a valid measure? Does it actually measure what we're claiming it measures? So reliability is simply about, do you get consistency in the measurement? So inter-rater reliability is one of the ways we can measure reliability, and that is the degree to which different judges independently agree upon an observation or judgment. And a lot of times when we're falling back on different ways of measuring variables, if what we're doing is actually having people watch a behavior or assign a behavior, or you're having people report on how someone else's behavior, we're often going to look at inter-rater reliability. We're going to have multiple people. So for example, if I ask for 3 family members to rate your agreeableness, do they generally agree on that score? If so, I have high inter-rater reliability. If 2 of your family members say you're extroverted and one of them says you're introverted, I would have low inter-rater reliability on that particular measure. This is one of the problems actually with the common Rorschach test that is one of the reasons it's only acceptable in one state currently in legal proceedings, and that's because it doesn't have high inter-rater reliability. It is a useful tool for counselors and clinicians to kind of get at how people are thinking. However, if you actually ask 3 different counselors to interpret someone's response to the same ink blot, you'll often get wildly different responses. That means there's not a lot of inter-rater reliability in this particular scale. So are items measuring the same thing as internal consistency or inter-item reliability? The degree to which all the specific items or observations in a multiple item measure behave the same way. And there's multiple ways to look at this. And this is internal consistency or inter-item reliability. So this is still at reliability. We're not really at validity yet. But what we're now asking is, if we have multiple items, are they measuring the same thing? One of the ways we can do this is Cronbach's alpha, and we'll be talking about that as a statistical technique. It basically simply takes multiple items and asks, what is the percentage of agreement? We can also do alternate forms reliability or split half reliability. Alternate forms means that we have two different tests with the same number of items with slightly different questions, but they're meant to capture the same construct. If we have alternate form reliability, people that scored well on Form A would also score well on Form B. People that scored poorly on Form A would also score poorly on Form B. Another way we can do this is split half reliability or even random reliability. So everyone is given the same test, but then we look to see, is there a high correlation between the first half of the test and the second half of the test, the odd questions versus the even questions, or randomly 20 questions versus the other 20 questions. Again, if we find high consistency, we're getting reliability at that point. So reliability is the measure measuring the same thing each time it's used. This can also be measured with test-retest reliability. The degree to which an item or a scale correlates positively with itself over time. So we give someone a personality test, 3 weeks later we give them the same test. We should find that their two scores should be highly related to each other. Maybe not perfect, they may not have scored an 89 both times, but if they scored between an 85 and a 95 the first time, we'd expect them to be in the similar range. We wouldn't expect someone to score a 90 the first time they take the test, and then when given the exact same test, them now score a 50. That would be a question of reliability. So let's talk a little bit about how reliability and validity connect to each other. So basically, can we have a reliable test and a valid test? Yes. Can we have a reliable and an invalid test? Yes. Can we have an unreliable and valid test? In most cases, no. So reliability is the first step. Because we're interested in relatively stable constructs, if we don't have a reliable measure, we really can't even talk about validity. That's one of the reasons we talk about reliability first. And it's one of the first things that we'll often defend statistically of a scale, that will show that it has reliability. But once it has reliability, it could be valid or invalid. Again, if I'm doing a measurement of height, it is probably highly reliable. If I say this measurement is meant to measure how tall someone is, it's also valid. If I say this measurement is meant to determine how much people like the Beatles, it's probably invalid. Probably height has no relationship to your like of a particular British boy band. So a test can be reliable but have no validity. However, if a test is valid, it will generally be reliable. So some final couple slides is just to kind of put these two together. This would be an example of a reliable but not valid scale. So think of it as a target, and you're taking each individual measurement is a shot at that target. If all the shots lump together, it's reliable. You are measuring the same thing. But if you're not hitting the bullseye, it's not necessarily valid. Likewise, if you actually, again, see a nice function of all the hits are around the same area, they seem to be measuring the same thing, and they're hitting the target, they're measuring what you're claiming it's measuring, it's reliable and valid. We'll talk more about validity as we continue in this class, but these are important things to consider when you're actually thinking about how statistics work. You need to know this information. You need to be able to categorize variables, not just because it's a part of this class, but it allows us to know what kind of statistics and what kind of analysis we can do. If we don't know what our variables are, if we don't know how they were measured, and we don't know what kind of measurement they are, we really can't move forward to a lot of these techniques we've talked about to look at both reliability and validity, but also to start looking for relationships.